I think that would be kind of cool.
Okay, 27 through 50, all is what we're doing today. I'm starting your homework with you, so here we go. Number 27. The directions in the textbook say for problems 27, I'm just so excited right now. So you need things like that to rejuvenate us as teachers. It says use the fundamental identities to simplify the expression. Use the table feature of a graph utility to check your result numerically. Okay, all this is basically saying is put it in simplest form. In other words, when you get this, graph the cotangent sine of x and then graph the other one and see if numerically everything matches up. So with that said, what do I know cotangent to be? Cosine of x over sine of x times the sine of x. Well, what happens to your sine of x? Cancel it. I'm left with cosine of x. When you plug this into F1 and this into F2, numerically their XY tables will match. Do we understand that?
Cotangent sine over cosine.
No. Tangent is sine over cosine. Cotangent is cosine over sine. Okay?
So do we have to put in the next line?
I'm not going to take time for that now.
But we
I
have
would
to-
like you to check. I would like, am I making you write it down on the paper? No. If you choose not to check this, that means you're choosing to just guess that what you have is going to happen. What I want you to do in here is simply add a new page, I want a graphs page, and I'm going to put in here the cotangent of x times the sine of x, and hit enter. And then I'm going to do cosine of x, and hit enter. Now, they like directly on top of each other. You can clearly see that. But if I hit Control-T for table, I can clearly see that they match. Everything but 0, done to fine. Okay? Now, that's what this is saying, and that's the whole point of identities. It's trying to get something that's really, really big down to a nice little neat package. Okay?
You get all.
It's happening.
You get
Okay, do we all understand that? Now, next one. 37. Same exact thing. 37. Same exact thing. So, what do I know cosine squared to be? I can't do anything with this, right? I can't do a darn thing with it. But what I can do, and what I do know, is that sine squared of x plus cosine squared of x is equal to 1. Yes? So if I know that, what do I know cosine squared to be?
One minus the sine squared of x.
Sorry. Now, every place I see the cosine squared, I simply am going to put in there 1 minus the sine squared of y, all over 1 minus the sine of y. Now, I'm not done, though, because I cannot cancel that out yet. What?
Put on the bottom, the cosine squared. Equal to that 1 over.
Because they're not squared.
Yeah.
You know what I'm saying?
That's all.
Okay. Now, with that said, I need to factor the top. So if I factor the top, that's going to give me 1 plus the sine of y times 1 minus the sine of y, all over 1 minus the sine of y. Did we see that? Yay or nay?
I had to throw it away. It got really gross. I completely forgot that was
1 minus sine y is cancel out, and I'm left with 1 plus the sine of y. If I graph this into F2, and I graph this into F1, their x and y numerical tables should match. Do we understand that? Moving right along, 43. 43. Verify the identity algebraically. Use the table feature graph utility to check your result numerically. Now, what's the difference with this? It's saying that the left-hand side, which is this nasty-looking junk, has to equal this little pretty package of 2 cosecant of theta. Yes, you have done this before, okay? It is more identities. Now, with that said, what you have to do is work the left-hand side all the way down to make it equal to 2 cosecant of theta. Do you understand that? So what do I have to do first?
You're gonna get a common denominator.
I need a common denominator. And what is my least common denominator between those 2 pieces of junk? Multiply them together. So I'm going to have the sine of theta times 1 plus the cosine of theta. Do we see that? Yes or no? Okay, which means I need the first fraction's denominator to turn to this. And I need the second fraction's denominator to turn into that. So what can I multiply sine of theta by to get that new denominator? So I'm going to drop down my 1 plus the cosine of theta from the original one, and then I'm going to multiply it by another 1 plus the cosine of theta. Why am I doing that? What you do the bottom, you do the top. Excellent job. So now, go to the next one. What do I multiply 1 plus the cosine of theta by to get the new denominator? Sine of theta. So I drop down my sine of theta that's currently up there, and then I'm going to multiply it by the sine of theta also. Because what I do to the bottom, do to the top. Okay? So now I have exactly the same junk going on here, correct? So now I'm going to marry the 2 fractions together, and while I marry them, can I FOIL in one step? Y'all okay with that if I FOIL? 1 plus 2 times the cosine of theta plus the cosine squared of theta plus sine squared of theta all over sine of theta times 1 plus the cosine of theta. Oh, this is exciting stuff. This is wonderful.
We're gonna have like 3 days until this week to try to catch up on everything.
Moving right along. Now, what do we know here? What do I notice? What should you be saying? Alarm, alarm, alarm.
Look at it.
Well, why can't you just cancel out?
No. You can only cancel things out. You can only cancel things out when things are all attached by multiplication. When things are attached by addition, that means you have head and body going on, okay? So what we do notice is that this junk right here is an identity. Do we see that? Because cosine squared plus sine squared is the value of 1. So what I actually have here is 1 plus 2 times the cosine of theta plus 1 all over this junk. And what is 1 plus 1? 2. So now I have 2 plus 2 times the cosine of theta all over the sine of theta times 1 plus the cosine of theta. No. Back to your alpha 2 skills. Yesterday we talked about multiplying or factoring. What's in common in that numerator? What's in common is they both have a 2. Do we see that? So if I pull a 2 out, I'm left with 1 plus the cosine of theta all over the sine of theta times 1 plus the cosine of theta. Now is everything attached by multiplication? Yes, which means now that can cancel out. I'm left with 2 times 1 over the sine of theta. Why did I write it like that? Why did I write it like that?
Over the
1 over sine.
I want you guys to see that that 2 is not part of our identities on that page that I gave you at the beginning of chapter 5 that I wanted you to memorize. But what so you do notice is that this is on that page. That's a very special value. And what trig function is that? It's the cosecant. And guess what? That's what I wanted. How can you not get excited about that?
How can you get excited?
How can you not look at that and say that's not beautiful, beautiful stuff?
I would have did the math class.
What happened to
That is
gold? Do these monthly
let's move sparkly on.
That's
Okay, 44.
I know.
44.
okay, I'm telling you now.
Not like that.
In all my free time, 3 homework assignments now.
Stop whining. It gets you nowhere in life, and you still have to do it in the end,
Talking about the spring break.
right? What's the point of whining whenever it's not going to help you,
Yeah, it really is.
and you still have to do it? Okay, so step 1, what do we notice here? The bottom needs to have a common denominator. My common denominator is going to be sine of theta times the cosine of theta. So can I skip steps, or are you guys going to like, oh, don't skip steps. Okay. So I have two fractions that need this new denominator. So what am I multiplying the first denominator by to get my sine theta, cosine theta? I'm multiplying it by cosine of theta. So I multiply by the cosine of theta and I drop down what's already there. Great? Okay, now, make sure that you know that's subtraction there. What am I multiplying the cosine of theta by to get sine theta, cosine of theta? Sine, so I multiply that by sine, and I drop down the cosine theta minus the sine theta. So what do I do? Vary them into one fraction and distribute. So this is going to be sine of theta, cosine of theta, plus cosine squared theta, minus sine theta, cosine theta, plus sine squared theta, all over sine theta, cosine theta. Line to that denominator is extremely challenged right now. It's got a little bit of a dip in it.
I think it's really so
A
much
little
on
bit.
the top.
It's just carrying all that weight.
It is. That top is kind of heavy. Okay, well, what happens? Those cancel out. Bam, bam, gone. Seventy.
Yeah.
Sine squared plus cosine squared is equal to 1. So now I have 1 over the sine of theta times the cosine of theta. What's 1 over sine?
The cosine.
What's 1 over cosine? It's a beautiful thing. Yeah, yeah. It's a beautiful thing.
We're still recording.
Yeah, yeah. I know. Math is beautiful. Don't you think?
No.
Don't you think? This is magnificent and beautiful. 48. 48.
That was before me.
48.
I'm sorry, I used up the lead in my mouth.
No, oops. No.
Sorry.
So what do I gotta do? I need a common denominator. So my least common denominator is going to be the tangent of theta times 1 plus the secant of theta. Yes? So now I need each one of those denominators to have that. So since you won't let me skip any steps, and this is why I've learned to write fast. Each denominator needs to have that. So what did I multiply 1 plus secant of theta by to get the new jump? Tangent. So I have the tangent of theta, and then I drop down the tangent of theta that's currently there. What do I multiply the second denominator by to get that? 1 plus secant. So I'm going to multiply that by 1 plus secant of theta, and drop down what is currently there. do I do? Nope.
Add together.
Marry them. We join these two in holy matrimony. Tangent squared theta plus 1 plus 2 secant theta plus secant squared theta. All over tangent of theta times 1 plus the secant of theta. Now, do you see how quickly I'm boiling in my head?
Yeah.
That's where you should be. That's where you should be. What did you say? Where is the identity? No. That's an identity, right? And what does that equal?
I don't know.
Secant squared?
It is secant squared of theta. Okay. This is a like term to this. It is not a like term to the 2 secant of theta. Why is it not a like term to the 2 secant of theta?
Because it's not square.
Because it's not squared. So what I have going on here is 2 secant of theta plus 2 secant squared of theta all over tangent of theta times 1 plus the secant of theta.
1 plus the tangent of secant is 1.
Come again? No, I can't hear you, honey. What did you say?
Like, isn't it a thing like a
An identity? Is what an identity?
1 plus the secant of theta?
No. You have squares. They all have to, all of your identities have to be squared, okay? Unless you're specifically solving for one of them, like secant or tangent, and then you're going to have the square root concept going on, okay? Now, do I have a GCF in the numerator?
2 secant.
Secant. Please pull that out. So that's going to give me 1 plus the secant of theta all over the tangent of theta times 1 plus the secant of theta. And what happens? This cancels out, and I'm left with 2 times the secant of theta times 1 over the tangent of theta. Why did I put it like that? Because I'm trying to separate all of my trig functions.
Why? Because you're just making them into more trig functions.
Yes, but generally speaking, we prefer not to have a fractional expression unless we absolutely have to. So what is 1 over tangent of theta? It is cotangent. But we're really not done yet. Because if I were to express, if I could express this in terms of sine and cosine, what is secant in terms of sine and cosine?
1 over.
This is 1 over the cosine of theta. And what is cotangent? Cosine of theta over the sine of theta. And then what happens? The cosines cancel out, and I'm actually left with 2 times 1 over the sine of theta. And what is 1 over the sine of theta? 2 cosecant of theta. Shebang! What's that?
Please joke.
We were going to kill so many trees with
That's a lot of work.
Yeah. Aren't these beautiful? Does nobody see the beauty in it all? Nobody makes it that little bit fun.
It's just too long.
I think
It's shorter if you
We
do.
talked about that.
At least
I think they're
I.
very challenging, very fun. It's like unwrapping a present without tearing anything and being able to wrap it back up in it afterwards.
And a small bag.
I just love it. It's amazing. Okay, that's all I have for you today. I did as many problems as I could with you right now. I want you guys to really think about it and really try to do some. I know you guys are stressing. I know you're stressing. Okay? But when it comes down to it, the only way that you guys are going to be able to do these is if you sit and try. I had to laugh yesterday because Nigel came to me and he said, oh, yes. He said, Mrs. Yoder, I don't understand this. And he did it, but then I showed him the other way. He was, oh, you're so smart. I didn't see it like that. It's not intelligence. It's the matter of practicing it to be able to recognize it, right? When you're driving somewhere and you learn a shortcut for the first time, do you memorize it right away? You try, but you might take a wrong turn every now and again, correct? Well, that's what this is like with these trait identities. Sometimes you're going to take a wrong turn, you're going to do the exact wrong thing completely. You just got to back it up and start from scratch.
I'm lost.